So good day everyone. I'm going to make a video about related rates, or shall we say time rates. So what exactly is time rates? By the way, let me introduce myself. I'm Josh and I'm a first year student in Bachelor of Science in Mechanical Engineering, and I'm doing this out of a learning process in our calculus class. So let's begin. What exactly is related rates? In differential calculus, related rates questions entail linking a variable to other values whose rate of change are known in order to determine a rate at which it changes. Usually, the rate of change is measured in relation to time. So which means when an object is moving, we find it with relation to time. When you're curious about a ladder goes down and when it is leaning on the wall, we solve for that one, which means we solve for how fast it is, and we need to find the rate of change behind that movement. So we have steps here in solving related rates. Number one is to draw a diagram for visualization, which means in order to visualize the following question, you need to draw a diagram in order to understand the question deeper. Number two is to identify the given units and quantities, which means you need to put the given quantities of the following questions in order to solve the questions with ease. Number three is put the equation relating units. Number four, derive with respect to time. So since we are looking for the rate of change, and the rate of change is solved with respect to time, therefore we derive it with respect to time. And lastly, we answer the given equations. So this step will help us find the desired result of our goal. So we have an example right here. Let me show the whole question. So we have example number one. Water is flowing into a conical reservoir 20 feet deep and 10 feet across the top at the rate of 15 cubic feet per minute. And we will find how fast the surface is rising when the water is 8 feet deep. So we will do the first step, which is to draw a diagram in order to visualize that question. So we have this one. You need to draw a cone because it says here it's a conical reservoir. Then it looks like this. I am having a hard time drawing a diagram, but it doesn't matter as long as you understand it, then it's no problem. Then we have a water that is 8 feet deep, so we need to draw that also. So it says here we have, wait a minute, we have a diameter. Is 10 feet. This will be 10. And this one, which means it is the height of the cone, we have 20 feet. And the height of the water inside of the cone, that will become 8 feet. Wait a minute. And we have a rate of change in the question, which means water is flowing at the rate of 15 cubic feet per minute. So it looks like that. And it is flowing at 15 cubic feet per minute. Oh, that's terrible, but should be understandable. So we have the diagram now, so we need to put the necessary equations needed to solve for this problem. So we have a rate of change, right? So since the unit is cubic means volume. When the unit has raised to 3 or it is cubic, then we have the volume, and it is changing with respect to time. So we derive the volume with respect to time, which will become dV over dt. So we have given it a 15 cubic feet per minute. We have this, and we have the diameter, which is 10, and the height, 20 feet. And also, we have the height of the water, Uh, that is how I label it. As long as we solve the problem correctly, that will be necessary. So we have 8 feet. Let this be one, the height of the water. Next is we need to identify the volume of the cone. So the volume of the cone, that will become 1/3 pi r squared times the height. So what's the next step? We need to find the r, this one. So we need to divide the radius with the height. So since we have a given diameter in here, we divide the diameter, which is 10, we will have a radius of 5. Remove that a little bit, so we have 5 over, we have a height of 20. Then we find r, find r, so we will have 1/4 per h. We simplify this one right here, will become 1/4 times the h. So we will substitute everything that we have necessary for the problem. So the volume become 1/3 pi, and we substitute the r with 1/4 h. Oh, that's a terrible looking h. And square it and times the height of the board. Then what's the next step of this? Of course, we need to simplify this one, of course. So we have volume 1/3 pi. Then one squared, that will only be 1. So 4 squared, that will have 16. So h squared times the h, we will have h cubed. So I made a mistake in putting a parenthesis in here. That this shouldn't be necessary. Oh, never mind, it's necessary. So what's the next step? So the next step is the climax of the problem, which means we need to find the rate of change. For short, we will derive it with respect to time. The main goal of this problem. So this one, we will derive it with d over dt. So this will become dv over dt equals to 1/3 pi 1/16. Then we derive h cubed, that will become 3h squared. We use the power rule for that. Then with respect to time, we have dh over dt. We have derived it. Now all we need to do is to substitute. So we have given right here, we have dv over dt in here. So we have 15. So we put 15 in here. Like that. Then 1/3 pi 1/16 times 3. Then we substitute the h with 8 because that's the height of the water. And we are looking for how fast this is rising. For short, that's the rate of change, right? We are looking for the rate of change of this one, so we need to put the height of the water in here. So that's 8. And square it times dh over dt. Since we are looking for the dh over dt, or the change of height of water in the cone. So we simplify this one. We have 15. Oh, we multiply this, 1 times 1 will become 1, and 3 times 16, that would be 48 pi. Then we have 3 times 8 squared, we would have 192. You need to put a parenthesis in here so that if you put it in your calculator, you won't have a syntax error. So we have here dh. Oh, I made a mistake. I didn't notice it. This should be dh over dt. Sorry about that. So we have this one. Then the next step is to divide this in order to be cancelled, and we will get our final answer. So We will make this easier. We'll have to copy paste this shit. Just like that. And this one will be cancelled. Then we copy this one. Oh, never mind. We will rewrite that 15 of 1 over 48 pi of 92, 192 rather. So this will be the equation of dH over dt. Sorry about that. I am actually having a hard time writing because I'm using a mouse. So we calculate this equation, 1 over 48 pi times 192. So we will get our final answer of 1.93. I mean 1.193. Sorry. 1.193. Then we put the unit because it is necessary to put a unit because we are looking for the relation with change and time. So feet per minute. So we have this is our dH over dt, and therefore we have our final answer. I hope you got it.